Hi, Algebra 2 honors students. This is going to be stats days 9 and 10 combined. 9 and 10 are actually kind of each short enough, and we'll wind up skipping a few examples here and there too, such that we can combine them into one lesson here. Here are the homework 8 answers. There was a homework 8 that was a review, but we're not quite ready to go through all those review questions yet. So the only thing I wanted you to accomplish was what says Unit 15, Day 8 homework. Sampling distribution of means and proportions. So go ahead and make sure you're comfortable characterizing whether things are population characteristics or sample statistics. These were means in this example. One thing we learned in the lesson is that the average of all your X bars, right? The average of all those averages is going to approximate mu, which is the population mean. So in this case, we can say that we know that the average of all those X bars should be 60. In terms of variability, the sampling distribution standard deviation is always going to be less than the standard deviation of your population because of the way we calculate those things. When you divide sigma by the square root of n, that's definitely going to be a number that's smaller than sigma. And the last case is something that will come up in today's lesson, and we're trying to come up with a range of values that captures 95% of the sample means. So 95% according to our normal curve is within 2 standard deviations of the mean. So if we add and subtract 2 standard deviations, this is the range of values that we would expect 95% of our boxes of Lucky Charms to be within in terms of the number of marshmallows that they have. Okay? So any questions about this, you'll let me know. Otherwise, we're going to jump right into day 9. Which, like I said, is really pretty closely related to what we're doing in that last part of homework 8 there. So we're going to be talking about the margin of error. Okay, so when you're doing these notes, try and have day 9 and day 10 in front of you if you are somebody who has them printed out, because we're going to go through both of those. All right, so margin of error. It's a measurement of how accurate our sample is. It gives us a range of population characteristics based on some sample statistics. Okay, so that range that we saw in that last question in part E, that has something to do with the margin of error. So if we go ahead and take a look at that same fact that we just went over, that 95% of normally distributed data falls within 2 standard deviations of the mean, the way we're going to calculate margin of error is by just adding and subtracting 2 standard deviations. Symbolically, that would be sigma of all your X bars, okay? So it's the standard deviation of all the means of your sampling distribution. So it's pretty much what we were doing yesterday anyway to get that range, but the margin of error by itself is just calculated by saying it's plus or minus 2 times the standard deviation of your sampling distribution. Okay. Quick interpretation of the margin of error here. Says it gives us a range of plausible values of population characteristics. So since we know that we're capturing 95% of our sample when we talk about margin of error, that range of plausible values is going to be vocabulary that does come up quite frequently. Is this value plausible? So if it's within 2 standard deviations of the mean, the margin of error, then we say yes, that value sort of makes sense. That's a likely possibility. If it's outside of that range, then we'd say, nope, it's not very plausible. It's not very likely that that will occur. So in the examples below, you're given some means and standard deviations of some sampling distributions of sample means. Calculate the margin of error. So all you're going to wind up doing in these examples is to calculate margin of error, use the formula at the top, add and subtract 2 standard deviations. And I'll tell you, we're not really getting to this plausible range part yet, so we're not going to do the range of values that fall within that. But for number 1, if the mean is 3.2, standard deviation is 0.6, we don't really have to know mu sub x bar to do this. It's really just relying on what is the standard deviation. So this would be plus or minus 1.2. And going across the line, I mean, we're not going to spend a lot of time with this. All you're doing in all these examples is doing plus or minus 2 times the standard deviation. Could I use this value, add it and subtract it from the mean to get that plausible range of values? Absolutely. It's not asking for that quite yet. So margin of error for this one's plus or minus 7.8. And if I go down the rest of the way, if you wanted to try those, those are the other margins of error. To take a look at example 2, the only difference now is that we're not looking at sample means, we're looking at sample proportions. So that's what all of basically day 8's lesson was based off of, the difference between looking at sample means within a sampling distribution and then comparing that to when we have sample proportions. So the way you calculate the margin of error is the same way. Just take plus or minus 2 times the standard deviation. The standard deviation is 0.05. You're going to get plus or minus 0.10 for your margin of error. And if you want to try those just real quick, I mean, I don't know how important it is for you guys to know how to double a number, right? I mean, you can double check those real quick. But that's pretty much what we're doing to calculate margin of error. What I think is more important, I think, is interpreting this in the context of a given problem. Okay, so what does the margin of error tell us about a given, set of data? And are certain other values that I might ask you about, are they plausible? Are they likely to happen? So if you go ahead and once you're solid that you know how to double some numbers, go ahead and take a look at the dot plot in example 3. It says below is a sampling distribution of sample means of 50 samples. So there's 50 dots below, each of size 10. The mean of the sampling distribution is 7.5, and the standard deviation is 1.7. So the first question says, how many values does each dot represent? So there's 50 dots, there's 50 samples, but each was of size 10. So each dot represents an n equal to 10. Next thing says, what is the margin of error? Well, we just saw 8 examples of calculating margin of error, plus or minus 2 times the standard deviation of 1.7. So that's going to be plus or minus 3.4. Then the next part, which we haven't done yet, is using the margin of error, find the range of plausible values for the population mean. So to figure out that range of plausible values, we're going to take the mean, which is 7.5, and then we're going to add and subtract that margin of error of 3.4. So if you subtract 3.4, you're going to get 4.1. And then if you add on 3.4, you're going to get a value of 10.9. So these are the range of values that seem likely. Now, we don't even really have a lot of context for what the data, represented up here. But with this range of values, what interpretation can I make about that range? So these are the plausible values. For the population mean. And they occur between 4.1 and 10.9. Right, so hopefully you would agree, and that's actually a pretty big deal in the study of statistics. So for those of you moving on to AP Stats next year or the year after, this 95% value is actually something that you'll see come up quite frequently. So coming up with a range of values that seems like, yep, those would be likely to happen. So is 3.5 plausible? Well, it's definitely not in that range. So no, because it is outside that plausible interval. So a 3.5 would not be likely to happen. Okay, and that's pretty much it. So the calculations in the stats is really, I think, pretty straightforward for now. But I think what will take a little bit more time to get used to is just, writing the sentences and interpreting some of the more the vocab heavy parts of stats. All right, example 4, suppose that students can rate their math class from 1 to 10, 10 being outstanding. You better all give me some 10s right there. Many random samples of 10 FHS students produce the following ratings. Okay, so we've got from our samples, the average of those X bars is 8.4 with a standard deviation of 1.9. So it says find the margin of error in a plausible interval, interpret the range in context. We have a little bit more context in this example as compared to the one up above. Let's first calculate that margin of error. So that would be plus or minus 2 times the standard deviation of 1.9, which is going to be plus or minus 3.8. Okay. So once I have the margin of error, the plausible interval is the average, right? Your mu sub X bar plus or minus the margin of error of 3.8. So that range is going to go from 4.6 to 12.2. So how do I explain what that interval of values means in the context of this problem? Okay, so the plausible values of the population mean of what is the context of this problem? The population mean of math class rating is between 4.6 and 12.2. Okay, so if I were to take a random sample of 10 FHS students, and I got an answer from 4.6 to 12.2, which I know 12.2 is not possible in this scenario. But anyway, any number in this range of values would be likely to happen. If I had a random sample of 10 students and I got a number below 4.6, then I would say, nope, it's probably not very likely that that will happen. I guess it could, but you found 10 very disgruntled math students in the high school, which is just not the case. All right, so is a rating of 8 plausible? Yes, simply because it's in the interval that we found up above. So pretty easy to make that determination, right? I mean, once you have the plausible range, you know, it's kind of a yes or no question, whether it's in the interval or not. Okay, the last question here is really just one more for practice, so we'll get to that in a moment. We've already talked about what plausible means. If it's plausible, it's in the interval within 2 standard deviations of the mean. If it's not plausible, that means it's just outside the interval. So nothing too exciting there because we've already talked about that. And then this margin of error for sample proportions is the same exact scenario where you're going to do plus or minus 2 times the standard deviation. Not really sure why this comes up here in the lesson because we already did this on the front page anyway. Right? We did it for sample proportions where we did plus or minus 2 times the standard deviation. Maybe just a quick reminder. So this last question, I'll just lead you through my answers quick and then we'll move on to day 10. This is an agency that collected 100 samples of 50 adults about their favorite soda. It was found that the average of the p-hats, the average of all your samples, is as a proportion of 0.31 that favor Coke. The standard deviation of the distribution of 100 sample proportions is 0.07. Okay, first part, based on the standard deviation, what's the margin of error for their sample proportion estimate? So plus or minus 2 times the standard deviation is plus or minus 0.14 in this case. Part B, what is the plausible range with 95% confidence? You might see that phrasing at times. Okay, so plausible range, 95% confidence. We can say with 95% confidence that we get something within that range because of the way we're doing our plus or minus 2 standard deviations. Okay, so that's going to be a range of 0.17 to 0.45. So if we get somebody that falls into this range right here of preferring Coke, we would say that the plausible values of the population proportion this time, right, as opposed to the population mean for the last one, of US adults that favor Coke is somewhere from 0.17 to 0.45. And then finally, is 0.41 plausible? Sure is. It's in the interval. So that's pretty much day 9. You can see why maybe the information went pretty quickly here because we already talked about some of this info in day 8. And now I think we're kind of ready to jump right into day 10. So if you go ahead and take a look at day 10, day 10's title is Evaluating Reports Based on Data. Okay, so we're going to take a look at some information and use some of our knowledge of what we know so far about statistics to make some conclusions and see if things just sort of make sense here. So the report says 89% of high school students want air conditioning. And although that will not be as much of an issue for us this year, if we were in school all the way until June, I bet many of you would say that. And in fact, this poll was conducted in June of 2015 at a randomly selected New York public high school. Okay, so a few public high schools, we gathered some data from students, 89% said they want air conditioning. The sample size is 2,500 students, and the margin of error is plus or minus 1.2%. So based on that, what do we know so far? We know N, okay? N is the sample size, right? So the sample size is given to us as 2,500 students. The margin of error in this case is given to us in a percent form. So what we might want to do is list that as plus or minus in decimal form. That would be 0.012. We have a sample statistic that's given to us. Okay, the sample statistic is actually given to us up here. That's our p-hat. So the p-hat is 89%, or if you want to list that as 0.89, we can do that. And then it says, is the margin of error correct? Verify using this equation. So this equation came up in yesterday's notes. So to find the standard deviation of those p-hats, you would do the square root of p times q over n. Remember that q, if p is the proportion of success, q is really, I guess, the proportion of failure, if you will. So that q value is really the same thing as 1 minus p. So what we need to calculate here is, do we have the square root of 0.89 times 0.11 is what the probability of failure would be here, right? 89% prefer it, 11% would not, over n, which the sample size here is 2,500. So let's see what that comes out to be. So the square root of, I'll do a fancy fraction under there. Oops, nope, don't want to do that. So alpha y equals 0.89 times 0.11 over 2,500. I'm getting that the standard deviation is 0.00626, something like that. Okay, so if that's the standard deviation, how would I use that to figure out if the margin of error was correct? Well, what happens if I double that? So if I double that, because remember it's plus or minus 2 standard deviations, I get 0.0125. I mean, yeah, I mean, we might have a little bit of rounding error here, but I would say, yeah, this is about 0.012. So that margin of error of 1.2% makes sense. Confirm. So this is the standard deviation we calculated. Margin of error of plus or minus 1.2%. Sounds good to me. All right, are there any flaws that we see in this study, though? Okay, so the margin of error all checks out. What might be some things that would have warranted these results? I mean, 89%, yeah, I'm going to vote for it too, but, well, guess what? Typically, it's hot in June. So if you had taken this survey in January, you may have gotten some different results because it's, you know, some students are sitting in my classroom freezing in January. Okay, so that could be something that would make this a flawed study. Some other things to consider is, hey, we're only talking about public high schools. So maybe if we had included private high schools, could we have gotten some different results? I'm not sure. And I hate to tell you this, but you know, if a school like Penfield was included, Penfield is air conditioned already. So I'm not sure what the results would look like if you survey students. Like, was that taken into account by the people trying to collect this data here? Okay, it's not very common that you see schools in our area that are air conditioned, but there are some. So, all right, so a quick jump into just some evaluation of reports here. Let's go ahead and take a look at, this will be the last example that we walk through together today, and then I'll let you guys kind of take a look at the homeworks that go with homework 9 and homework 10 here. So example 1, it says, the following is part of an article that appeared in a newspaper. With the election for president still many months away, true story for us right now, right? A new poll shows that the race is close. The Republican nominee has 47% and the Democratic challenger has 45% in a poll that was released Tuesday of 800 registered voters. Okay. So the first question says, oh, sorry, that's within the poll's margin of error. So we know the margin of error is 3.5 percentage points, making it essentially a toss-up, said the polls director. We're going to come back to that in a little bit as to why we can't really determine who we think the winner will be because of these percentages and that margin of error here. Okay. Well, first of all, why do those percentages not necessarily add up to 100%? I guess it depends on how well versed you are with politics as to how you might want to answer this question. There are kind of two things that I came up with. There might have been, when this poll came out, there might have been some undecided voters. So they would not be included in the Republican percentage or the Democratic percentage. Okay, and then the other part of this is that, there are other candidates who run for the presidency other than Republicans and Democrats. So those would include like third party candidates, maybe they're, an independent candidate. There are definitely a lot of other different types of parties that are not as popular or as common as Republican and Democratic parties are, but they're out there. So maybe there's some people who decided to list that when they were responding to the poll. Part B, what is meant by the margin of error of 3.5 percentage points? Okay, so what we know about that margin of error is that the true population proportion of the approval ratings is within 3.5% of the mean. Okay, so because of that margin of error, we don't know that it's exactly 47% who are going to vote for the Republican nominee. It's within 3.5% of that value. Okay, so 3.5% above or below that proportion. Okay, so moving on to the next page. At the top, it says using the sample size of 800 and the proportion 0.47, calculate the margin of error associated with the estimate of the proportion of all registered voters who would vote for the Republican governor. Okay, so in this case, what we want to do is just sort of confirm that the margin of error really is what it was stated as, which was 3.5%. So in order to do this margin of error calculation, we're going to do plus or minus 2 standard deviations. And to do that, we are not given the standard deviation. If you look back at the information that we were just looking at, we didn't know that, but we know how to find the standard deviation given sample proportions. It's going to be that same formula we used a moment ago, n times q over n, or sorry, p times q over n. So p is the proportion that are voting for the Republican candidate. 0.53 would be the percentage not voting. And we're going with 800 as our sample size n. And if you type that in the calculator, well, luckily, the poll was successful in calculating the margin of error because you wind up getting 0.0353. Okay, so that does conclude that we have a 3.5% margin of error. So based on that margin of error, why did the poll directors say that the election is essentially a toss-up? So if we look at the Republican plausible range here, so what would that do? I would take the average, the 0.47, and then add or subtract this margin of error right here. So I'll tell you the range for the Republican nominee is from 0.4347 to 0.505. Okay. On the other hand, the Democratic nominee, remember that the population proportion for the Democratic nominee was only 0.45. But again, if you add and subtract that margin of error, 0.45 plus or minus this value, you're going to get a plausible range from 0.4148 to 0.4852. So why is this election a toss-up at this point? It's because with the margin of error, notice how these two intervals, they overlap with one another. So since there is still some overlap, the conclusion is unknown. Okay. So with that overlap, we really can't tell who will win according to the specific poll. So how might we be able to combat something like that? Maybe we would take a look at an increased sample size. So the sample size was 2,500 registered voters. And the results stated that 47% would vote for the governor, that's Republican, 45% for the Democrat. What would the margin of error now be? And could the director still say that the election was a toss-up? I'd encourage you to pause, go ahead and try this. Okay, we have to recalculate the margin of error because we have a different sample size, so we know that the standard deviation is going to be reduced because as sample size increases, that variability decreases. Go ahead and try this, see if there's still that overlap, and if so, it's still a toss-up. If not, we're good to go. And when you're done hitting pause, I'll show you the answer quick. All right, so here are the calculations that you should have done. It's the mean plus or minus 2 standard deviations. Here's the new standard deviation calculation. You can see that there's still some overlap here in the plausible ranges. Okay, here's what I got for the plausible ranges. So because there's still some overlap between these two groups, it's still essentially a toss-up. We can't tell even after increasing that sample size for the poll. All right, so it really is just that close that it's going to come down to seeing what happens on election day. All right, so that's pretty much it for today. I'll tell you we can skip example 2. Don't worry about the last one. I think this is enough about evaluating reports for you guys to be able to answer the questions successfully on homework 10. But if you have any questions along the way, as always, send me a quick email and we'll take care of it. All right. Oops, hit the wrong button. All right. Talk to you guys soon.